So the topic that we're getting into right now is just a supplementary tool to go along with our IPO charts. And the IPO charts, of course, their purpose was to organize our thoughts. What we're going to talk about today is something called a flowchart, and it's really to organize the layout of our programs. So yes, we can transfer our IPO charts directly to code, but sometimes there can be a more visual way of demonstrating that design, which can be very useful when coming back to old programs and whatnot to understanding what's going on without having to really dissect the code and understand how it flows within itself. And what you see on the right hand side of the screen here is an example of a very basic program in flowchart form. Basically, this program asks the user for the radius of a circle. It reads in that radius, it calculates the area of the circle and the circumference of the circle, and then displays those results back to the user. And of course, it has a start and an endpoint. We know that it goes in this order because of the direction of the arrows. This is why it's called a flowchart. It demonstrates the flow of the program. Very straightforward. There are 4 types of flowcharts that we're going to look at over the course of this semester. The first one, which is today, is called a sequence, and that's just an ordered sequence of operations in our program. So we can see a sequence. There's no divergence of the arrows, there's no forks in the arrows or anything like that. Later on, we're going to look at decisions, cases, and repetition within our flowcharts. But for now, we're going to keep it simple. So as you can see on the right-hand side here, these flowcharts are made up of arrows and symbols. And each symbol, the arrows represent the flow of the program, as we've already mentioned. We can see here, there's a lot of different types of arrows. What you'll notice is that there's no angled arrows. They're always either horizontal, vertical, or elbowed. And see here we have a joining set of arrows, and we're going to get into that later, but we're not really there yet. The second shape we look at is something called a rounded rectangle. Just a terminal. Terminal is just like a bus terminal, start and end. You get on, you get off. So in our case, we have one start and one end. And every flowchart should only have one start and one end. Everything should come back up and meet in and join back into this end. So that is our rounded rectangle. So there should only be 2 in the program. And then we get into a parallelogram. So a parallelogram, basically a rectangle that's kind of pushed over on its side a little bit, the angled. And a parallelogram is used for input-output operations. So things like displaying things like output to the user. Please enter the circle radius. So this is a prompt. It's also used for input operations. So the input operations are things like read in the radius. Right? Now you'll notice that we're still using some fairly easy keywords here just to make sure that it's clear what's going on. We see display, which tells us we're going to be displaying something on the screen. We see read, which tells us we're going to be reading in certain data. We see calculate, which tells us we're going to be processing some information and calculating something specific. What you'll notice is just like the IPO charts, it's general in nature. There's nothing specific to any programming language here. It is all completely general. You'll also notice that there's no variable definitions. Even in the IPO charts, we defined variables. In the flowcharts, we don't bother. We just use them and assume that the programmer can handle creating their own variables without any further pushing in any direction. And the things like pi and whatnot, again, depending on the language the programmer is working in, that might be something they need to define or maybe pre-built within the language itself. So I've told you the main shapes, and that's all you see inside of this diagram here. There is one other shape. Oh, sorry, I apologize. I missed one. The rectangle. Processing. This is kind of the most important one now that I get back to it. Processing is where all the calculations are done. You see, we only have 2 processing operations in here, calculating the area and calculating the circumference. But really, it's made for any type of non-IO operation that's occurring. So that means even assignment statements of variables, not defining, assignment. So you might see like set pi to 3.14. That would be an assignment statement, and that would be in a rectangle. These calculations are obviously processing, so they would also go inside of rectangles. And as I was mentioning before, this is pretty much all the basic shapes that you're going to have. We're going to go into a few more later on once we get into a few of these other types. But these are the basic shapes we're going to work with. Using just these, we've covered everything we've covered in the class so far, and it allows us to create our sequence. Now, because this is a sequence and it's going to go on a vertical line, you might run into the problem that you may go past the end of your page and you might not be able to fit it all. Well, that's where this circle comes in. it's called a connector. So basically, if we assume that let me just draw a line in here. So let's go to draw and come up in here. Let's say that the end of the page ended right here. What you could do is, instead of going into the parallelogram here, you could actually put a connector here with a label, let's say A, and then later on in the page, instead of going vertically down, beside it, you could continue off by creating another connector with the associated same label inside, A. And then I would go on, and I would continue on with that parallelogram we see below there. And this, again, is only used if you run into the end of the page. Some students have come to know these things as little teleporters that teleport you to the rest of the program. But it's just called a connector. It just means connecting you to the rest of the flowchart when you're out of space, just to keep your programs clean and clear. So that's pretty much it for design. We've talked about IPO charts, we've talked about flowcharts, and we are going to extend the idea of flowcharts later on, but for now, this should be everything that we need. And thank you for listening.